All right, so this is the video for the 6G handout. And let me make the screen full screen here. Okay, so the first one is really just review. It's not anything new. So we'll just work our way through this proof. So the given info is that AXY, so this angle right here, is congruent to angle C over here. Notice that's not the usual setup that we have, where it's like this angle and this angle go together, which then forces these lines to be parallel. So in this one, we just know that this angle and this angle are the same, not that one. So I don't know if these lines are parallel or not. So let's go ahead and put the given down. So angle AXY is congruent to angle C as given. Okay. And I'll draw the two triangles separately because they're going to overlap here. So here's A, X, Y, and there's the first angle that we knew. And here's the bigger one, A, B, C, and there's the angle that we know. So let's see what else. This gives us one pair of angles between those two triangles. I don't know if the Y angle right here is going to be the same as that B angle. But what we could do that's easier is match up A with itself. So this A and that A are the same exact angle. So angle A is congruent to itself. So that's reflexive. So there's another A, pair of angles. So then that's enough to say, well then I know that this triangle and this triangle are going to be similar because of AA similarity. So in our proof, if I call the first one AYX, so AYX goes, let's see, the way that I did it, it went from two curves to no curves to one curve. So this one would be ABC, two curves to no curves to one curve. So ABC. And then after that, we want to match up. In this case, we're going to be aiming at sides. We're going to match up corresponding sides. So let's take a look at where these are. AX is this one right here. Sorry. It's this side right here between the two and the one curve things. So that's going to go with this one over here. And then XY is the one that connects the one curve to nothing. So that goes with this one over here. So then if we set up a proportion, we've got AX over AC, so little blue over big blue, equals little green over big green, BC. And that's because corresponding sides of similar triangles are in proportion. Or CSSTP if you want to use the abbreviation. Okay, and then that's all there is to that proof. It's a fairly short proof. The only reason that that's in here is I don't want you to always assume that just because you have that these lines are always going to be parallel. And in this case, you can't even prove that. We do know that this equals this one. That's all that we're starting with, though. Okay, that being said, I have mentioned that triangles that look like this are going to come up a ton in this unit. And here's where we start really getting into detail on how that works. So in this problem, they already tell you SL and IP are parallel. Okay. Now, we can prove some theorems about this stuff. I just kind of want to get you to the point where you have a good feel for what works and what doesn't work. So what I'm going to do is I'm going to scroll way down here to where it's blank. And I'm just going to draw in a similar looking thing. So here's a triangle. Let's make this one longer. And then I'm going to draw a parallel right here. And then I'll label some sides here. So let's say that this side is little a, this side is little b, or b is just this part, by the way. So it's just a small chunk. This is C, this is D. I'll make this thing E and this thing F. Okay, now, and then there's also G and H right here. Okay, so some proportions, there are more proportions than just using the two main triangles. But if we use that, we can set up some right away. So here's A, C, G, and then in the big triangle, here's E, F, and H. And because of the parallels, we know that those two angles are the same and these two angles are the same. And so you know the triangles are similar. And then we can set up a whole bunch of proportions like A goes with E, the same way that C goes with F, and it even goes the same way that G goes with H. So there's one proportion we can set up. But we can also do some other stuff, like if I do A over G in this triangle, that's the same as E over H in that triangle. So we can set up stuff like A over G equals E over H. You can kind of get a feel for a lot of these. You can sort of guess. Like if I said, what do you think A over C equals? Well, A over C is the left side of the small triangle over the right side of the small triangle. And that corresponds with E, the left side of the big triangle, over F, the right side of the big triangle. So you can kind of guess that's going to be E over F. And there are a whole bunch of these that you can sort of guess your way through. Now, so some of the ones that are less intuitive involve these little chunks down here, the B and the D. So, but you can still kind of get a feel for how these work. Like if I said, what do you think A over B is the same as? Well, that's the top part of the left side over the bottom part of the left side. Well, that's going to be the same as C over D right here. C over D. Okay. So there are a whole bunch of things that you can sort of get. If I said, what about A over E? Right? That's the top part of the left over the whole left side. Well, that's going to go with the top part of the right over the whole right side. Right? So that's going to be C over F. So you can take lots of guesses on these things. The ones to avoid are things that don't quite feel right. Like you're never going to match up A here with D there. That doesn't really make any intuitive sense why you would match up A with D. Maybe you match up A with B or A with E, you know, or down here when you're looking at the individual triangles, like A with G might make sense. But you're never going to kind of cut across this whole shape and go A goes with D, right? One that students make a mistake on all the time would be something like, what if I said, how does, let's see here, let me get it here. How does C, if C goes with G a certain way, so C goes with G equals blank over H. So if I say C goes with G, a lot of students guess, well, D goes with H. But that's not actually right. So C and G are the right side of the small triangle over the bottom of the small triangle. H is the bottom of the whole triangle. So if I said left side of small over bottom of small, or sorry, right side of small over bottom of small, then I'm going to need the whole right side of the big triangle over the whole bottom side of the big triangle. Whoops. So that goes with the whole thing H down here, F and H. So you kind of have to be careful about what you're matching up. It's easier to see that one if you split up the two. C over G is the same sort of relationship as F over H. Okay? So let's go back up to number 2 and see what we can come up with. So I'll also draw the triangles separately here. So here's F, L, S, and here's F, I, P. And since these are parallel, we know this angle goes with that one, this angle goes with that one. So we've got similarity for sure, AA similarity. Okay, and then let's match some stuff up. So let's see, Fi over Li. So if I do this whole thing over just the bottom part, The question is that the same as this whole thing over that bottom part? And that should feel like it makes sense. So this one is true. Okay, so let's try another one. How about Fs over Fl? Okay, so it's the right of the small triangle over the left of the small triangle. Is that the same as the right of the big triangle over the left of the big triangle? Well, yeah, that should feel right too. So this one's also true. Okay, so let's look at the next one. Part C says FL, this one over this one, FL over FL over FS. Is that the same as this little part over that little part? And that one is also correct. That should feel like it should make sense, which it does. So this one's also true. Okay, excuse me there. FI over FL. So that's the whole left side over just the top part of the left side. Is that going to be the same as, so the whole over part equals FS, the part here, over that thing right there. That should feel weird. That shouldn't seem right that those should be equal, and it's not. Generally speaking, that's not going to be the case, so this one's false. Okay, let's try another one. FL over IP and LI over FS. Wow, that I feel like we're jumping all over the diagram there. That one doesn't really, that shouldn't make any intuitive sense why that would be true. So this one is also false. Okay, let's try another one here. So FI over FP, so the whole left of the whole right. And we're checking, is that the same as the bottom left over the bottom right? And that should feel like it's a good match, which it is. It turns out this is true. Okay, let's try another one. FL over LS. So this one over that one. So in this picture over here, it's this over that. Is that the same as LI over IP? So that's this over that. And this is the one a lot of students think it's right. But if you think about how IP is involved over here, it would have to be FI over IP. So FL goes with LS the same way FI goes with IP, not LI. So this one's actually false. That's one that, this is the most common mistake one I think that I see. Let's take a look at the next one. Let me get rid of these blues. Okay, so the next one says FS, that's this, over FP, that's this. So that's this side here over this side here. And then LS, this one. Oops. Ugh. Let's try this again. So I'll do blue here. This one over IP, this one. So that's this one over that one. And that should look good. It's small right side over big right side equals small bottom over big bottom. So this one is true. And then we got one more to test here. So the last one says LI, I'll use green here, LI over FS. Already that should feel kind of weird that you're crossing across the diagram like that. The bottom left over the top right seems sort of weird. And then we've got FL over SP. And while that kind of feels like maybe there's a pattern to that, if you think about it, LI is small and FS is big. So there's no reason that a small number over a big number should be the same as a big number over a small number. So this one, you're kind of crossing across the diagram there. Well, that's a no-no. We don't really want to jump across the diagram like where these lines are going to cross here. So this one ends up being false. Okay. So, by the way, these things, I sort of lump them into something called triangle proportionality. The book, I think, narrows down which ones are which ones technically are triangle proportionality theorem. I don't care if you call them all the triangle proportionality theorem. So there you go. So that's number 2. Number 3, it's not a triangle, but you can actually use the triangle proportionality theorem, the same kind of properties that we came up with up here. So let me show you. Now, you might guess, oh, 5 over x equals 7 over 9, which is correct. Or 5 over 7 equals x over 9, which is also correct. But if you want to see how that works, just imagine that you slide this one over. So if you slide this one over to here, then you form little parallelograms right here. So this guy is x, and this guy is 9. And now you've got a problem that looks like this. 5 here, x here, 7 here, 9 here. And then you can use one of the same properties that we discussed just a minute ago, where like this one over this one equals this one over that one. Right? So you can do it like that. You could say 5 over x equals 7 over 9. You could split the triangle into 2 parts and say 5 and x here. Here's the big triangle. This is 12 and 9 plus x. I think that one's a little more annoying. But you could set it up 5 over 12 equals x over 9 plus x. Let's choose one that's a little easier. And this one only works because of the parallels. Remember, the parallels are the key to this. So if we do 5 goes with, let's say, x, the same way that 7 goes with 9, then the next line will be 45 equals 7x, and then we just divide by 7, and we get our x. Okay. Let's take a look at 4. So 4 says we know AB is parallel to CD. And we have to find the missing sides, which are this one here and this one here. Whoop. Okay, so let's call this one x. So we've got the parallels, so I know 5 goes with x the same way that 6 goes with 3. So if I cross multiply, we got 15 equals 6x. So 15 over 6 equals x, which is the same thing. Let's see, that can be reduced. So 5 over 2. So there's x. Oh, and x, we made x up. It's really AC equals 5 over 2 or 2.5, whatever you want to call it. Okay, AB, we'll call that y. This one, you can't, I think it's easier to draw the 2 triangles separately whenever you're dealing with one of the parallels. So if I do that, I'll draw them over here. So here's the small triangle. This one's 5, 6, 4. And here's the big triangle. And this one's 5 plus x, 9, because it's 6 plus 3, and y. And because of the way that the parallels work, we know how to match up our sides. Our sides match up exactly the way they look. This one goes with this one, the same way that this one here goes with this one there. So if I start with the small triangle, we'll say 6 over 9. 6 goes with 9 the same way that 4 goes with y. And so if I cross multiply, 6y equals 36. Y ends up being 6. Okay. And then in the bottom one, okay, so we still know AB and CD are parallel in the problem. And in this one, AE is 9. So this whole thing here is 9, which means this part, since this part's 2, this has to be 7. And so we're solving for CD and BD. So let's do BD first. So I'll call BD X. And so we've got the parallels again. So if I match up 7 goes with 2, the same way that 6 goes with x, then I got 7x equals 12. So x equals 12 sevenths. Okay. By the way, you can do this, and you could say like 2 over x equals 7 over 6. That also works. You'll still, the very next line is going to be this one anyway. So it works out pretty quick regardless. Oh, I made a mistake. Y up here is really AB. We made up the y. So AB is 6. Here, x is BD. So BD is 12 over 7. Okay. And then the second one, we need this. So I'll call that y for now. And then this is one that I think it's probably a good idea to draw them separately so that you don't accidentally use only part of a triangle. So this would be 9 for the whole side, 10 right here, and then this is 6 plus x. I'd like to avoid that because x is a fraction. So we know that the 7 is going to go with the 9 the same way that the y is going to go with the 10. So 7 over 9 equals y over 10. And so 70 equals 9y. So y is going to be 70 divided by 9. And that doesn't simplify at all. And then that's the same thing as CD is what y is. So there we go. And that is it for the lesson. Hopefully that wasn't too tough and that the proportions kind of... the goal is to get an intuitive feel for it. That's what I want you to get out of this, is which proportions are okay to set up when you have these parallels and which ones should you avoid. So, okay, hope that helps, and I'll see you guys tomorrow or sometime soon. All right, take care.